we just looked at the problem for two variables which is discussed. Now the very first thing we have to do is we have to find the frequency distribution in terms of probability for these two variables. So in this case, the arrival time between arrival and frequency is given. So we have to compute cumulative frequency, cumulative probability, and finally we have to assign the random number for these variables. Similarly, we have to do for service also. So let us do for time between arrivals. So cumulative frequency would be 2. Here it would be 2 plus 6, which is, let's put a formula and copy it out. 2 plus 6, which will be 8. Now I am going to copy this formula through so that this is computed quickly. So here what you see is, like, if you take it here, there is a 63. This is previous cumulative plus the current frequency. So 43 plus 20 is 63. So that way you can explain each one of them. Now you can see here there are 100 readings or 100 data points. So from that perspective, cumulative probability would be very simple. This would be frequency divided by 100. So here 0.02, in this case 0.08, 0.18, so on and so forth. So let us copy this frequency, this particular formula, you get the cumulative frequency distribution. Now let's look at the random number assignment, which is very important. Here this would be, since the random numbers are 00 to 99 and distribution is also 01 to 100. So we need to assign like 00 to 01 here. This would be 02 to 07. And this would be, normally the way we start is, let's take the previous one, which is 08 here and one number less here. So 08 to 17, this would be 18 to 42, this would be 43 to 62, this would be 63 to 76, here it would be 77 to 86, here it would be 87 to 93, here it would be 94 to 97, and in this case 98 and 99. This is the random number assignment for arrival time. Similarly, we have to compute frequency, cumulative probability, and random number for service time also. When you compute this, you will get numbers which is shown here. This is the cumulative frequency, once again 100 here. This is the cumulative probability. This is obtained by dividing 12 by 100, 33 by 100, and so on and so forth. And this is the random number assignment, the way we have done here. Now next step for doing this is really like creating a suitable table. As I mentioned, format of this table depends on the situation. So now here, since we are supposed to be calculating waiting for service and station idling, for doing these two, we have to find out what is the time of starting the service and what is the time of ending the service. Therefore, the format will look like this. Now 10 random numbers for arrival and 10 random numbers for service has been given. So let us populate this particular thing with arrival time and service time. So for populating with arrival time, let's copy this distribution just next to this table so that referring becomes easy. And here 78. Now look at 78 here. This means 3.5. So the time over will be 3.5 because 78 is here and that corresponds to 3.5 time between arrival. Similarly here also 3.5. 6. Now 6 is in the second group, time will be 1. 4 again in the second group, time would be 1. 97 is here, time will be 4.5. 71 is here, time will be 3. 78, time will be 3.5. 59 will be here, time will be 2.5. And 5 is in the second group, time will be 1. And 95, time would be again 4.5. These are between arrival times. Now, if I have to translate this time on a continuous time scale, then the first customer arrives at 3.5 minutes, second customer arrives at 3.5 plus 3.5, 7 minutes, third customer comes at 8 minutes, Fourth comes at 9 minutes on clock time, 13.5 minutes and 16.5 minutes. Next one, and then this is 20 minutes. And this is 22.5 minutes, 23.5 minutes, and 28 minutes. These are the arrival time of customers on a scale on a time scale. Now let's find out service time. I'll do the same thing. I'll copy the service time distribution so that we can read it without any difficulty. So let's take the service time distribution from here and copy over there. So let's copy this. Here is the service time distribution. Now number is 54. So 54 lies here. So service time would be 1.5. 1.5 minutes will be service time. Second number is 26, which is service time will be 1 minute here. Third number is 51, which comes here again 1.5 minutes service time. 45 again 1.5 minutes. Then next one is 46, 1.5 minutes. 84, which is 2 minutes. 58, let's look at 1.5 minutes. And 58 again 1.5 minutes. 60 again will be 1.5 minutes. And 24, second category is 1 minute. These are the service time. Now based on this data, let's look at when the service starts. When the first customer arrives, which is at 3.5 minutes, so service arrives at 3.5 minutes. It takes 1.5 minutes to serve him. So service will end at 3.5 plus 1.5, which is 5 minutes. And obviously waiting for service. Customer in this case, the moment he arrives, he is being served. So his wait time is 0. The station is idling for 3.5 minutes because clock has started at 0 time, and the first service he gets to do is at starting at 3.5 minutes. Now let's look at the second one. Now it is end of service is 5 minutes, but customer arriving at 7 minutes. So therefore the service will start at 7 minutes here, and 1 minute is the time taken, service time 8 minutes. Now idling for customer is 0 because the moment he comes, service starts, and idling for machine would be, because machine gets free at 5, starts at 7, so 2 minutes here. Now let's look at this case. Now 8, here also is 8, so service starts at 8, and 1.5, so 9.5 it will get over, and 0 waiting and 0 waiting here. You look at here, because 8 passenger comes, the customer comes, and service starts at 8. Similarly, machine also gets free at 8 and service starts at 8. Now here 9.5 and 9, since it is getting over at 9.5, therefore service will start at 9.5 minute, and it will go up to 11 minute. 9.5 plus 1.5. Now here customer came at 9, service starts at 9.5, so he is waiting for half a minute, and there is no waiting for the machine. Now next one, 13.5. So service starts at 13.5 because next customer comes at 13.5, and it goes up to 15 minutes. So waiting time for customer is 0 because the moment he comes, service starts. Waiting time for machine is 2.5 minutes. 11 and 13.5 minutes. So 13.5 minus 11, so 2.5 minutes. Next one. Now here service starts at 16.5 minutes because customer is coming at that time. It goes for 2, so 18.5 minutes. And now look at the waiting time here. 16.5, so 0 waiting time for customer and 1.5 minute for service station, because service station was free at 15 minutes, but service starts at 16.5 minutes only. Now here service starts at 20 because customer is coming 20 minutes, and it takes 1.5, so 21.5. Now here, since it comes and immediately starts, 0 waiting for customer, but waiting for this one is 1.5 minute. Now here 22.5, 21.5, so 22.5 service will start, and this is 1.5 minute is taken as service, so 24, again 0 minutes here, and it would be 1 minute over here. Now in this case 24 machine, station is getting free, and person comes at 23.5, so service will start at 24, and it takes 1.5, so 25.5, Now this is half a minute waiting for customer because he comes at 23 and half, but service starts at 24. So half minute wait time for him and 0 wait time for here. Now in this case, let's look at customer comes at 28, which is higher than 25. So service will start at 28. It goes for 1 minute, 29, and 0 wait time for customer and 2.5 minute wait time for 2.5 minute wait time for service station. So you see, out of the 10 simulations or 10 arrival and 10 service pattern, what we find is 1 minute time customer is waiting and 15 minute time service station is waiting. And what is the total time which we have spent in the system? We started at 0 minutes